The request for a single-phase supply for audiovisual systems is a common practice in the industry, particularly for high-end or critical listening applications. The rationale behind this request is to minimize electrical noise and interference that can affect the quality of the audio output. While the industry may cite common practice as the reason for this request, there is limited technical evidence to support the superiority of single-phase systems over multi-phase systems. The main argument in favor of single-phase is that it eliminates potential ground loops and reduces common mode noise. A ground loop is an electrical circuit that exists between two or more electrically connected points that are at different ground potentials. When a multi-phase system is used, the neutral conductor carries both the return current for the phase currents and the stray currents from the equipment. This can create a potential difference between the neutral and grounding conductor, leading to ground loops. Common mode noise is a type of electrical noise that appears in equal magnitude on all conductors of a circuit. This type of noise can be caused by electromagnetic interference, such as from nearby equipment or electrical wiring. Single-phase systems are less susceptible to common mode noise because the neutral conductor is not carrying any phase currents. Other factors to consider include power quality, system design, and cost. The quality of the power supply can impact the performance of audiovisual systems. Single-phase power is typically more prone to voltage fluctuations and harmonics than three-phase power. The design of the audiovisual system itself can also influence the need for single-phase power. Well-designed systems with proper grounding and noise mitigation measures may not require a single-phase supply. Single-phase transformers are generally more expensive than three-phase transformers. While the request for a single-phase supply for audiovisual systems may be common, there is limited technical evidence to definitively support its superiority over multi-phase systems. The decision of whether to use single-phase or three-phase power should be based on a thorough analysis of the system design, power quality, and potential noise sources. If this issue is present, consulting with an experienced electrical engineer or audiovisual specialist to determine the best course of action is recommended. Let's delve deeper into these concepts. Ground loops arise from having multiple paths to ground, creating unwanted current flow and noise. In a multi-phase system, the neutral conductor serves as the return path for current and can also carry stray currents, leading to a voltage difference between the neutral and ground. This voltage difference can then induce current flow through the ground connections, creating the ground loop. Common mode noise, appearing equally on all conductors, can be generated by electromagnetic interference from various sources. Single-phase systems theoretically reduce this noise by isolating the neutral conductor from phase currents. However, in practice, the effectiveness of this isolation depends on factors such as the quality of the wiring and grounding. The quality of the power supply significantly affects the performance of audiovisual systems. Single-phase power is more susceptible to voltage fluctuations and harmonics compared to three-phase power, which can impact the stability and clarity of audio and video signals. Harmonics are distortions in the sinusoidal waveform of the alternating current, which can introduce noise and interference into the system. The design of the audiovisual system plays a critical role in determining the need for single-phase power. Properly designed systems with effective grounding and noise mitigation techniques may not require a single-phase supply, as they can effectively minimize noise and interference through other means. Furthermore, single-phase transformers are typically more expensive than three-phase transformers, adding to the overall cost of the system. The decision to use single-phase or three-phase power should be based on a detailed analysis of the system design, power quality, and potential noise sources. This analysis should consider factors such as the sensitivity of the audiovisual equipment, the grounding practices in the building, and the presence of potential sources of electromagnetic interference. Consulting with an experienced electrical engineer or audiovisual specialist can help determine the optimal approach for minimizing noise and interference in the system. Understanding grounding and bonding is critical to understanding the single versus multi-phase AV electrical design. Grounding refers to connecting electrical equipment to the earth, providing a low impedance path for fault currents to flow back to the source. Bonding refers to connecting different metal parts of a system together to create a common ground potential. The National Electrical Code, NEC, provides detailed requirements for grounding and bonding in electrical systems. Proper grounding and bonding are essential for safety and for minimizing electrical noise. Multiple grounding points can create ground loops, as mentioned earlier, so it is important to follow the NEC guidelines for grounding and bonding. Single-point grounding, where all grounding conductors are connected to a single point, is often recommended for audio-visual systems to minimize ground loops. This can be achieved by using isolated ground receptacles, which have a separate grounding conductor that is connected directly to the main grounding bus in the electrical panel. Another important consideration is the use of shielded cables. Shielded cables have a conductive layer that surrounds the conductors, providing protection against electromagnetic interference. The shield should be properly grounded to be effective. Surge protection is also important for audiovisual systems, as surges can damage sensitive electronic equipment. Surge protective devices, SPDs, should be installed at the main electrical panel and at the equipment to protect against surges. Power conditioning equipment can also improve the quality of the power supply by filtering out noise and regulating the voltage. Power conditioners can help to minimize the impact of voltage fluctuations and harmonics on the performance of audiovisual equipment. It's also worth understanding balanced versus unbalanced audio signals. Balanced audio signals use 3 conductors, 2 signal wires, and a ground wire. Unbalanced audio signals use 2 conductors, 1 signal wire, and a ground wire. Balanced audio signals are less susceptible to noise than unbalanced audio signals because the noise is induced equally on both signal wires and is cancelled out at the receiving end. Therefore, balanced audio connections are recommended for long cable runs or in environments with high levels of electromagnetic interference. When dealing with audiovisual systems, impedance matching becomes critical. Impedance is the opposition to the flow of alternating current in a circuit. Impedance matching is the process of ensuring that the impedance of the source is equal to the impedance of the load. Impedance mismatch can cause signal reflections, which can degrade the quality of the audio or video signal. Therefore, it is important to use equipment with the correct impedance and to use impedance matching transformers if necessary. When troubleshooting noise issues in audiovisual systems, a systematic approach is essential. Firstly, identify the source of the noise. This can be done by disconnecting equipment one at a time to see if the noise disappears. Once the source of the noise has been identified, the next step is to determine the cause of the noise. This may involve checking the grounding and bonding, the power quality, and the cabling. Once the cause of the noise has been identified, the appropriate corrective action can be taken. This may involve improving the grounding and bonding, installing surge protection, or using power conditioning equipment. The National Electrical Code, specifically Article 640, covers audio, video, and similar systems. This article provides requirements for wiring, grounding, and protection of audiovisual equipment. It is important to follow the NEC requirements to ensure the safety and performance of audiovisual systems. Article 640.3 covers the supply circuits and interconnecting cables. Supply circuits for audio and video equipment must be installed in accordance with the NEC, including requirements for overcurrent protection and grounding. Interconnecting cables must be suitable for the application and must be properly supported and secured. Article 640.4 covers the access to equipment. Audio and video equipment must be readily accessible for maintenance and repair. This may involve providing access panels or removable equipment racks. Article 640.5 covers the wiring of equipment racks. Equipment racks must be properly grounded and bonded, and the wiring must be neatly arranged and supported. Article 640.6 covers the overcurrent protection. Audio and video equipment must be protected by overcurrent devices, such as circuit breakers or fuses. The overcurrent devices must be sized appropriately for the equipment. Article 640.7 covers the grounding. Audio and video equipment must be properly grounded to provide a low impedance path for fault currents. The grounding conductor must be sized in accordance with the NEC. Article 640.8 covers the bonding. Audio and video equipment must be properly bonded to create a common ground potential. The bonding conductor must be sized in accordance with the NEC. Article 640.9 covers the surge protection. Audio and video equipment must be protected by surge protector devices, SPDs, to protect against surges. The SPD must be sized appropriately for the equipment. Article 640.10 covers the wiring methods. The wiring methods used for audio and video equipment must comply with the NEC requirements. This may include using conduit, cable trays, or other approved wiring methods. Article 640.11 covers the separation of conductors. Audio and video conductors must be separated from power conductors to minimize electromagnetic interference. Article 640.12 covers the installation of equipment. Audio and video equipment must be installed in accordance with the manufacturer's instructions and the NEC requirements. Article 640.13 covers the marking. Audio and video equipment must be marked with the manufacturer's name, voltage, current, and other relevant information. Regarding single-phase power in audiovisual systems and the NEC, it's important to note that Article 647 addresses sensitive electronic equipment, while Article 647.3 mentions a special transformer with a single-phase secondary rated 120 volts line-to-line and 60 volts line-to-neutral. This configuration is not commonly used and may be more relevant for specific types of sensitive equipment beyond typical audiovisual setups. The more pertinent aspect within the NEC for general audiovisual installations is ensuring proper grounding and bonding as outlined in Article 640, regardless of whether a single-phase or three-phase power supply is used. The focus should be on minimizing ground loops and common mode noise through effective grounding practices and the use of shielded cables, rather than relying solely on a single-phase supply as a noise reduction method. When evaluating the need for a dedicated single-phase circuit for audio-visual equipment, consider the total current draw of the equipment. If the total current draw exceeds 80% of the branch circuit rating, a dedicated circuit is generally recommended. For example, if the equipment draws 16 amps continuously, a 20 amp circuit would be appropriate. It is also important to consider the voltage drop in the circuit. Excessive voltage drop can cause equipment to malfunction. The NEC recommends limiting the voltage drop to 3% for branch circuits and 5% for feeders. To calculate the voltage drop, use the following formula: voltage drop equals 2 times K times A times D divided by circular mils, where K is the constant dependent on the conductor material, I is the current in amps, D is the distance in feet, and circular mils is the cross-sectional area of the conductor. If the calculated voltage drop exceeds the recommended limits, increase the conductor size to reduce the voltage drop. Understanding the difference between series and parallel circuits is crucial for proper audio-visual system design. In a series circuit, components are connected end-to-end, so the same current flows through all components. In a parallel circuit, components are connected side by side, so the voltage is the same across all components, but the current divides among the components. Audiovisual systems typically use a combination of series and parallel circuits. For example, loudspeakers are often connected in parallel to increase the overall sound output. When connecting loudspeakers in parallel, the total impedance of the speakers decreases. The total impedance of parallel speakers can be calculated using the following formula: 1 divided by total impedance equals 1 divided by impedance 1 plus 1 divided by impedance 2 plus 1 divided by impedance 3, and so on. It is important to ensure that the amplifier is capable of driving the total impedance of the speakers. Using an amplifier that is not rated for the impedance can damage the amplifier of the speakers. In summary, proper design, installation, and maintenance of audiovisual systems require a thorough understanding of electrical principles, NEC requirements, and audiovisual system design best practices. While a single-phase supply may be beneficial in some cases, it is not a substitute for proper grounding, bonding, and noise mitigation techniques. A comprehensive approach that addresses all potential sources of noise and interference is essential for achieving optimal performance. It is recommended to consult with experienced professionals to ensure that the audiovisual system is designed and installed correctly. Single-phase power might be requested to address specific noise concerns, but it's vital to understand the technical basis and weigh the pros and cons against other noise reduction strategies. Don't solely rely on single phase as a magic bullet for noise issues. Focus on proper grounding, shielding, and system design for a more robust and effective solution. Consider the specific equipment and the environment when making decisions about power supply. What works in one situation may not be optimal in another. And always prioritize safety and compliance with electrical codes. Remember that the goal is to provide clean, stable power to the audiovisual system while minimizing noise and ensuring safe operation. Proper planning and execution are key to achieving this goal. The design should take into consideration the long-term use and any additions needed in the future. This will help to ensure a system that continues to provide optimum results for years to come.